last class we have solved some problems of a structure of atom of NCERT book. Now we are going to solve some more problems of this chapter. That is question number 2.16. The first part of 2.16 is the energy associated with first orbit of hydrogen atom is minus 2.18 10 power minus 18 joule per atom. What is the energy associated with fifth orbit of hydrogen atom? Energy of first orbit is minus 2.18 10 to the power minus 18 joule per atom. So we have to calculate energy of fifth orbit. Energy of fifth orbit of hydrogen atom. Energy of fifth orbit of hydrogen atom is equal to energy of first orbit of hydrogen atom divided by 5 square, because you know that energy is equal to minus 13.6 electron volt Z square by n square, and minus 13.6 electron volt is energy of first orbit. So in energy of 1h divided by 5 square, hydrogen is same, so Z is cancelled again, Z is 1, so you don't have to consider Z. 10 power minus 18 divided by 25. This is the energy of fifth orbit of hydrogen atom. Second part is telling that calculate the radius of Bohr fifth orbit of hydrogen atom. Second part is radius of fifth orbit of hydrogen atom as is what? As you are knowing that RNH is equal to 0.529 angstrom n square by Z. So if you have to calculate R5H, that is going to be equal to 0.529 angstrom, and 5 square divided by 1, that is equal to 25 into 0.529 angstrom. This is the radius of fifth orbit of hydrogen atom. Question number 2.17. Question number 2.17. Calculate the wave number for the longest wavelength transition in Balmer series of atomic hydrogen. We have to calculate the longest wavelength of Balmer series in hydrogen atom. As you can see that for longest wavelength we have to consider the minimum energy difference. For lambda longest we have to calculate delta A smallest, and delta A smallest means for Balmer series means transition is occurring from n is equal to 3 to n is equal to 2. So 1 by lambda correspond to this one, R1 square, 1 by 2 square minus 1 by 3 square, that is equal to R 1 by 4 minus 1 by 9. You will have R 36 and 5. So 5 R by 36. So lambda longest will be equal to 36 by 5 R, where R is Rydberg constant. You can easily see that. For maximum lambda you have to see the minimum energy difference, and for minimum lambda you have to see the maximum energy difference. That's the concept. For minimum energy difference you have to see the adjacent transition, whereas for maximum energy difference we have to see the energy transition from n is equal to infinity to n is equal to that particular orbit. Question number 2.18. In this question is what is energy in joule required to shift one electron in hydrogen atom from first orbit to fifth orbit, and what is the wavelength of light emitted when electron returns to ground state? The ground state energy of hydrogen atom is given as minus 2.18 into 10 power minus 11 joules. We have to calculate energy in joule that is required to shift electron from n barabar 1 to electron in n barabar 5. This is the energy in joule required. From first orbit to fifth orbit we have to do transition. Now energy of first orbit is given as minus 2.18 10 to the power minus 11 joules. This is the energy of first orbit. Energy in joule we have to calculate. So first of all I am calculating it, converting it into energy in joule, that is equal to this one joule, 2.18 into 10 power minus 18. 2.18 into 10 power minus 18 will be the energy in first orbit of hydrogen atom. Energy in fifth orbit is going to be equal to E1 divided by 5 square, means E1 divided by 25. So energy in joule required will be equal to delta E between 1 to 5, that is equal to E1 E5 minus E1, and that is going to be equal to 24 by 25 E1 with minus sign E1, and that is going to be equal to 24 by 25 into 2.18 10 power minus 18 joule. This is the energy required to shift electron from n is equal to 1 to n is equal to 5. And again the second part is telling that what is the wavelength of light emitted when de-excitation occur, electron de-excitation occur, energy of photon emitted will be same as energy required for excitation. Because from both theory you know that the energy of photon emitted is equal to energy difference between two orbits. So energy of photon is going to be equal to 24 by 25 into 2.18 10 power minus 18 joule. And so we have it is told that wavelength of light emitted, so Sc by lambda is equal to 24 by 25 into 2.18 10 power minus 18 joule, and you can calculate it easily as 6.626 10 power minus 34 into 3 into 10 power 8 divided by lambda is going to be equal to 24 by 25 into 2.18 10 power minus 18. In this way you can easily calculate lambda as equal to 6.626 into 3 into 25 divided by 24 into 2.18 into 10 to the power, this is going to be equal to 10 power, you can easily calculate it as 10 power minus 8 I think, 10 power minus 8 I think, because 10 power, this is 8 here, this is going to be equal to 26, and this is going to 10 power minus 8 meter. This is the wavelength that is emitted when electron undergo transition from n power 5 to n power 1. Question number 2.19. Question number 2.19. The electron energy is hydrogen atom is given by, in hydrogen atom electron energy is given as 2.18 10 to the power minus 18 divided by n square joule. This is the energy given is hydrogen atom. Calculate the energy required to remove electron completely from n is equal to second orbit. What is the longest wavelength of light in centimeter that can be used to cause this transition? So first of all we have to calculate energy in second orbit. We have to calculate ionization energy of electron in n power 2, and lambda for this one will be what? First of all we have to calculate ionization energy from electron in n power 2, and second part is lambda of photon that is required for such transition is what? So E2H will be equal to minus 2.18 10 power minus 18 divided by 4. This is the energy in second orbit. Ionization energy of electron in power 2 will be equal to simply minus of energy in power 2, that is equal to 2.18 divided by 4 in 10 power minus 18 joule. This is the ionization energy of electron in power 2. Now lambda of photon can be calculated also. Lambda of photon that is required will be equal to, since we have to calculate energy of photon must be equal to 2 at least minimum energy required will be equal to this one, and if minimum energy is this one, so lambda maximum of photon will be equal to 2.184 in 10 power minus 18, and in this way you will have lambda max will be going to be equal to 4 into 6.626 into 3 10 power minus 34 into 3 into 10 power 8 divided by 2.1 at 10 power minus 18. and in this way you will have 4 into 12 means this is 12 into 6.626 divided by 2.18, and this is going to be equal to 10 to the power minus 16 or 16 and 10 to the power 8, 10 to the power minus 8 meter. This is the lambda maximum that can be calculated easily. This is 2.19. Now we will have question number 2.20. In question number 2.20, the question is calculate the wavelength of electron moving with a velocity of 2.05. The speed of electron is given as 2.05 10 to the power 7 meter per second, and we have to calculate lambda of electron. Lambda of electron can be easily calculated as h by p of electron. H by p of electron means h by mass of electron or speed of electron, and 6.626 into 10 to the power minus 34 divided by 9.11 10 to the power minus 31 kg into 2.05 10 to the power 7, and that is going to be equal to 6.626 into divided by 9.11 into 2.05 into, you will have 10 to the power minus 3, and this is going to be equal to speed, mass into a speed, that is going to be equal to lambda. We have to calculate. This is going to be equal to 10 to the power minus 3, and this is going to be equal to 10 to the power minus 10 meter. This is the wavelength of electron moving with a speed of 2.05 10 to the power 7 meter per second. Simply we have to calculate de Broglie wavelength, because electron is a particle. If electron has a wavelength, it definitely will be de Broglie wavelength, and hence we have to calculate a de Broglie wavelength simply. Question number 2.21. Question number 2.21 is mass of an electron is 9.1 10 to the power minus 31 kg. Its kinetic energy is 3 10 to the power minus 25. Calculate its wavelength. Given that mass of electron is 9.1 10 to the power minus 31 kg, kinetic energy of electron is given as 3 into 10 to the power 25. So we have to calculate lambda of electron. Lambda of electron is simply equal to h by p of electron, and h by p of electron can be simply written as 2m kinetic energy, because you easily know that kinetic energy is equal to p square by 2m. So p can be easily written as 2m into kinetic energy under root. So in this way we can calculate it. 6.626 into 10 to the power minus 34 divided by under root 2 into mass 9.1 10 to the power minus 31 into kinetic energy 3 into 10 to the power minus 25. This is the value that you can calculate here. 6.626 divided by under root 9.1 into 6 into 10 to the power minus 25 here, 10 to the power minus 31 here, 25 and 31 and 25. You will have 6 and here is 5, and if you subtract under root here, so you have 28 10 to the power minus 6. This is the value that can be calculated easily if the kinetic energy is this one. This can be calculated easily because this is going to be equal to 25 and 56. 56 under root means 28. 28 if it is going upside, that is added here. So added here means 10 to the power minus 6 meter. So lambda will be equal to this one. Question number 2.22. Question number 2.22 is, among which of the following are isoelectronic spaces having same number of electrons? Given as Na plus, K plus, Mg2 plus, Ca2 plus, S2 minus and argon. Number of electron we have to calculate. 11 minus 1, that is equal to 10. Here you will have 19 minus 1, that is equal to 18. 12 minus 2, that is equal to 10. Here you will have 20 minus 2, that is equal to 18. Here you will have 16 plus 2, that is equal to 18. And here you will have 18. So sodium plus and magnesium 2 plus are isoelectronic. And now potassium plus, calcium 2 plus, strontium, sulfide and argon are isoelectronic, having same number of electrons. Very easy question. We have to calculate simply. Now we have to simply count the number of electrons present in any ion or atom. This is the question number 2.22. Question number 2.23 is first part. Write the electronic configuration of following ion H minus, Na plus and O2 minus and F minus. We have to write the electronic configuration here. It can be easily written as 1s2. It can be easily written as 1s2, 2s2, 2p6. It can be easily written as 1s2, 2s2, 2p6. And it can be easily written as 1s2, 2s2, 2p6. I have just counted number of electrons here. In each case, here it is 2, here it is 10, 10, 10. And hence electronic configuration of Na plus, O2 minus and F minus will be same, because these are isoelectronic spaces. Second part we have to calculate what are the atomic number of elements having outermost electronic configuration. Outermost configuration is given. Electronic configuration is given. This is 3s1, this is 2p3 and this is 3p5, and we have to write element which has electronic configuration, outer electronic configuration of this one. 3s1 correspond to sodium. Sodium has a configuration of 3s1 outermost. 2p3 has configuration of nitrogen. Nitrogen has 2s to 2p3, and 3p5 has configuration of chlorine. So chlorine has, because chlorine is in third period and it has 7 electrons, 3s to 3p5. So these are the elements that is outermost electronic configuration given here. Third part is question number, this is the third part again here. Third part is, it has been given that outermost electronic configuration is helium 2s1, neon 3s2, 3p3, and here again argon 4s2, 3d1, and we have to indicate the atom which is represented by these electronic as lithium. Here you will have phosphorus, here you will have scandium. This is the first element of D block, scandium. You can easily write because electronic configuration you easily know that. 2.24. What is the lowest value of N so that G orbitals can exist? G orbitals has L value of 4. As you are knowing that L barabar 0 means S orbital, L barabar 1 means P orbital, L barabar 2 means D orbital, and L barabar 3 means F orbital, and hence L barabar 4 is equal to G orbital. So G orbital, as you are knowing that for any given n, value of L will be equal to 0 to n minus 1. So if L is going to be equal to 4, so n has to, for L is equal to 4, n must be equal to greater than equal to 5. So the minimum value of n that allow G orbital to exist is n is equal to 5. So n is equal to 5 will allow G orbital to exist. For G orbital to exist, n is equal to 5 should be there. Question number 2.25. Question number 2.25. Question number 2.25 is an electron is one of the 3D orbital. An electron is in one of 3D orbital. Electron is in 3D orbital. Give the possible value of N, L and Ml for electron. Means 3D orbital means N value is 2, N value is 3, L value is 2, and now Ml value can be anything from -2, -1, 0, 1 and 2. There are 5 3D orbitals. If electron is present in any one of the 3D orbitals, then Ml values of those orbitals can be from -2 to +2. Anything. Question number 2.26. Question number 2.26. Here you will have an atom of element has 29 electrons and 35 neutrons. 29 electrons and 35 neutrons here. The question is telling that deduce the number of protons. Protons will what? Number of protons will be what? And electronic configuration we have to write. Electronic configuration we have to write. We know that atom is neutral. Atom is neutral. So number of electron, number of proton will be equal to number of electrons. Number of electrons, that is going to be equal to 29. And if number of protons and number of electrons are equal, you can easily calculate the number of electronic configuration can also be written simply as 29 electrons means it is copper actually 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d 9. However, you can see that this is not going to be a stable. You have to write it as 4s1, 3d 10 because to attain a stability, fulfilled configuration is achieved. Copper will be more stable if fulfilled configuration is written here. You can also write it as argon 4s1 3d10. This is the configuration of electronic configuration of atoms having 29 electrons. Question number 2.27. Question number 2.27 is give the number of electrons in a species H2 plus and then you have to calculate in H2 minus and then H2 and then you have to O2 plus. You can easily calculate number of electrons. 2 minus 1 that is equal to 1. Here you will have 2 and here you will have 16 minus 1 that is equal to 15. Plus means electron is subtracted, minus means electron is added. Here is easily calculated this one. Question number 2.28. 2.28 is there is three part here. First part is an atomic orbital has n value 3. What is the possible value of L and Ml? N value is 3, so we have to calculate L and Ml. L is equal to 0, 1, 2, and for Ml values you can see that Ml values for each L will be equal to minus L2 plus L. So these are the set of values of N, L and Ml for n is equal to 3. You can easily see that. Second part is list the quantum numbers Ml and L for 3d orbitals. 3d orbitals, for 3d orbitals we have to list the L and Ml value. For d orbital, as we have done previously, that for d orbital L value is equal to 2, so Ml value is equal to minus 2, minus 1, 0, 1 and 2. All are possible in this case. The third case is which of the following orbitals are possible? Which of the following orbitals are possible? 1p, 2s, 2p, 3f are possible. This is possible and this is possible. This is not going to possible. This is not going to possible because in n value 1, L can be only 0. So 1s orbital is possible only. In n value 3, L can be 0, 1 and 2. So 3s, 3p and 3d orbital is possible only. 3f orbital cannot exist. In n is equal to 2, you can see that L is equal to 0 and L is equal to 1 is possible. So 2s, 2p orbital can exist. So 2s, 2p orbital exists, but 1p and 3f orbital is not going to exist here. We have to see the quantum number, set of quantum numbers for any given n. L can take values from L 0 to n minus 1. For any given L, Ml values can be from minus L to plus L. Now question number 2.29. Question number 2.29 is using SPD notation, describe the orbitals with which the following quantum numbers. A part is n is equal to 1, L is equal to 0. B part is n is equal to 3, L is equal to 1. C part is n is equal to 4, L is equal to 2. And D part is n is equal to 4, L is equal to 3. We have to write the notation of orbital. This is 1s orbital, this is 3p orbital, this is 4d orbital and this is 4f orbital. L is equal to 0 means S, L is equal to 1 means P, L is equal to 2 means D, L is equal to 3 means F orbital. Question number 2.30. Question number 2.30 is explain giving reasons which of the following set of quantum numbers is not possible. A is equal to, N is equal to 0, L is equal to 0, ML is equal to 0 and MS is equal to plus half. Not possible. N can't be equal to 0. Not possible. This is wrong. N can't be equal to 0. N start from 1, 2, 3, 4, etc. So this is wrong. B part is N is equal to 1, L is equal to 0, ML is equal to 0 and MS is equal to minus half. This is possible. N is equal to 0. For N is equal to 0, L can take values from 0 to N minus 1 means only 0 is possible. So L is equal to 0 is allowed. ML values from minus L to plus L and 0 is allowed. So this is correct. C part is N is equal to 1, L is equal to 1, ML is equal to 0 and MS is equal to plus half. Again this is not going to be possible because L cannot be equal to 1 for N is equal to 1. For N is equal to 1, L can take values only up to 0. From 0 to 0, only 0 is allowed here. So this is going to be wrong here again. Question number D part is N is equal to 2, L is equal to 1, ML is equal to 0 and MS is equal to minus half. This is again going to be possible because nothing is wrong here. For N is equal to 2, L can take values from 0 and 1, 0 to 1. So 0 and 1 is allowed, ML can take values 0 and this one. So this is correct. E part is N is equal to 3, L is equal to 3, ML is equal to minus 3 and MS is equal to plus half. This is again wrong because for N is equal to 3, L can't be equal to 3. This is again wrong. For N is equal to 3, for N is equal, this is wrong and this is again wrong. This is correct, this is correct. And for F part, you can see that N is equal to 3, L is equal to 1, ML is equal to 0 and MS is equal to minus half. This is again correct. For N is equal to 3, L can take value 0, 1 and 2. 1 is allowed. ML can easily, for L is equal to 1, ML can have value minus 1, 0 and 1. So 0 is allowed. So this is correct. So this is the correct one. So 3 are wrong. A, C and E are wrong, whereas B, D and F are correct.